What's up, music nerds? I'm back with the second half of Chapter 14 of Hermann Helmholtz on the Sensations of Tone. This chapter is on tonality in homophonic music, and you can find the link to the webbook that I'm reading from in the description below. The entire text of the book is there, as well as the apps that I'm going to show you today. So let's get to it. At the end of last video, we got to this notation that expresses the exact intonation of notes. Notes with no subscript are defined by perfect fourths or fifths, and ones with a 1 in the subscript are defined by a major or minor third. Helmholtz has written the tonal modes of the ancient Greeks and Old Christian Church in this notation. We have the major mode, mode of the fourth, minor seventh, etc. Pythagorean intonation is notated like this. They are all belonging to the same series of fifths. I'm going to play them both. If you have a really good ear, you should be able to hear the difference. I maybe could hear the difference in this E in the third, but even that I'm not sure of. Now, when we construct Pythagoras' diatonic scale from this series of fifths, we get two kinds of intervals: a whole tone and the lemma. Though we do have a translator's note here, based on the use of the tetrachord, it seems more likely that the Greeks would have used a series of fourths rather than a series of fifths, which he denotes here, but we'll soldier on. So we have a diatonic scale whose intervals are whole, whole, half, whole, 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 half. But why stop with such an uneven scale? We can continue the series of fifths on and find an entire series of semitones within our octave. Which brings us to the Arabic and Persian musical system. We are still using a system of fifths in which this E is a comma higher than E, which is the natural third of C, written E1. However, if we tune a series of fifths downwards from C, which is listed here, we eventually get to F flat, almost exactly E1. Here is the math. They are just 2 cents different. So practically speaking, F flat equals E1, C flat equals B1, G flat equals F1 sharp, etc. Though the translator is going to use this accent here to denote the difference. All right. Persian and Arabic scales divided the octave into 16 intervals. Here is the notation we've gone over. A straight line indicates an interval of a Pythagorean lemma, and this curved line indicates a Pythagorean comma. Let's listen. Abdul Qadir assigns, hold on, let me tell you who that is. Abdul Qadir, a celebrated Persian theorist of the 14th century of our era. He laid down 12 principal tonal modes, or makamat. Helmholtz has compared them to the ancient Greek modes and found these first 3 are identical to these modes in Pythagorean intonation. These next 5 are not as obviously analogous to the Greek scales, but they are justly or naturally intoned, which we can see with the notes that have the subscript here. And these last 4 each have 8 tones, which Helmholtz says, if rightly reported, is a very singular creation. Now, of course, you can click on any of these scales to hear them, but you can also go down here to this app, choose one of these modes, and you can play a tune with your keyboard. That's analogous to our Pythagorean major scale. Let's try Buselic. Husseini. And then, of course, our modes with 8 notes. We also have especially if you have a MIDI keyboard that you can plug in, that is a very fun app to play with. But moving on, a new musical system was developed in Persia with 12 semitones to the octave, analogous to the modern European system. Apparently, the presiding hypothesis was that Christian missionaries introduced the 12-tone scale to Persia, but Helmholtz doesn't buy it. He thinks that it's more likely that these tones separated by a comma were over time melded together, and we arrived at a 12-tone scale. He even suggests the reverse, that European crusades actually brought back bowed instruments and the use of a leading tone from the East. In ascending passages going to the tonic, a preference has been given to the major seventh in all modern keys, even in those to which they do not properly belong. This transformation appears to have begun in Europe during the period of polyphonic music, but not in part songs only, for we find it also in the homophonic cantus firmus of the Roman Catholic Church. The sharpening of the leading tone was omitted in writing, but was supplied by the singers. The general introduction of the leading tone represents, therefore, a continually increasing consistency in the development of a feeling for the predominance of the tonic in a scale. In the gradual development of the diatonic system, therefore, the various links of the chain which bound the tones together were sacrificed successively to the desire of connecting all the tones in a scale with one central tone, the tonic. The further development of the European tonal system is due to the cultivation of harmony, which will occupy us in the next chapter. Subscribe to the channel so you don't miss my video on that next chapter. And go to sensationsoftone.com so that you can play in the Persian and Arabic tonal systems on your keyboard. I also know that we had a commenter on the last video who is an expert on this topic, so I would love to hear their thoughts in the comments below, and your thoughts too, whether or not you're an expert on the topic. And I'll see you in the next video. Bye!